Hello Harko and Scott, this will be a somewhat rough video on the dataset you just sent me, and what I've done is swapped father and mother, so it's sire followed by Dan, and then I've added a field index and I've just put in a uniform random between 0 and 1 there, and a column called max use, which I'll look at in just a second. You'll see quite a lot of duplicate IDs like this one, but I think that's a bit of history that's not throughout your file, and you can find a list of them here. Number 5 will be in there somewhere, and there's that one bisexual individual which is 1531, meaning that that individual is listed in both this column B and this column C. Now max use is the maximum number of matings that you're allowed to have for each individual, and I've set that to 1 near the end of the file, just for a bunch of animals that have got both parents known. And of course you can override that with the file imp1 group, so that over here, if I put in 25 there, it means that each male could be used for 25 matings maximum, as opposed to -1, meaning read it from the data file and what you see there is what you will get. So let's go on and look at running the data set. Here it is. So first of all, it builds a frontier. And makes a run. So progeny index is just a random number, that's not important. Parental co-ancestry is more important, and we're constraining that a little bit, but let me just update that and not put any constraint on anything. Now, I'm not sure what you want to do really here. I put the number of matings to be made just to 10, and if we look at progeny inbreeding for an individual, well, let's look at one. If we look at the current solution, these are the matings to be made, the 10 matings to be made for this solution up here, and these are the progeny inbreedings, prog F. Now progeny inbreeding is the same thing as the co-ancestry between the two individuals, so the co-ancestry between these two individuals is 0.59. And we can see the progeny inbreeding in a graph. Here's the distribution of progeny inbreeding values. And the red line is just the mean of that, and the green line is the value of the most inbred progeny, which is 0.8359 approximately up here. Now let's say, for example, you were wanting to go for an experiment where you have, let me just go ahead and do this. I'm going to increase variation and I'll put just a moderate weighting on that at the moment, and that increases the variation to, as you can see. So this would be where you want to have a bunch of matings where you have highly related individuals and a bunch where you have lowly related individuals, which might be just a thumbs up here. When we show the matings, we can see we've got the lowly ones, 0.48 or so, and the highly related ones, and we can change the numbers in there because we've got 6 and 4, but we could change that. And the reason you might have that is because you want to do an experiment where you've got higher related individuals for donors and hosts and lowly related individuals for donors and hosts. And you could do things like make these have a certain trait profile and these have a different trait profile in addition to the co-ancestry. All that sort of stuff could be done. And of course, alternatively, you could simply aim to increase the mean or any other component like that. So here we go, we want to increase it. The scales change quite considerably here, and this is still being constrained by wanting a high index. So if I go to put the weight on frontier to 0 and update, that means we're paying no attention to these two issues at all. Then you can see all the inbreeding coefficients have climbed through the roof, and the graph goes a bit funny. This is a bit of an unusual situation. And if we look at the mate selections and update that, we can see we've got high inbreeding coefficients, which means that these individuals are high co-ancestry with each other, the highest possible out of the number of candidates you've got, if that is what you were after. And it may be somewhat different. Let me just remove that constraint and go to individual co-ancestry. This is the average co-ancestry of each individual with the rest of the selected population. So if you are wanting to go for a fast rate of inbreeding, you would increase the mean. And that means that everything is as highly related to everything else as possible, not at the level of individual pairings, but for all the individuals that are going to be selected if we update that. It's not just that these levels are quite high, it's the all possible relationships you've got amongst all those individuals to give you longer term inbreeding. So that would be, if you were trying to get a highly inbred population quickly, you would be doing something like that. So I've only touched on this. There are a bunch of other things, of course, that you can do. The important thing is that the progeny inbreeding values are equal to the co-ancestry between each individual. So not only do you have access to that for the whole thing, in fact, we have calculated, and you can print out quite easily, and if you look in the manual, you can print out that full set of co-ancestries between all male and female candidates if you want to. You can have that information, but you might as well use that information in this tool, because it, I think, will give you whatever you want to do in terms of manipulating those co-ancestries and finding the pairs of individuals that need to be matched with each other for either breeding or for tissue graft experiments. Okay, let me know how that fits. All the best. Cheers now.